Okay, so first of all, prove true for n equals 1. So it's 3 to the 2 times 1 plus 1, plus 2 to the 1 minus 1, 3 to the 3 plus 2 to the 0, 27 plus 1, which is 28, 7 times 4. So which is divisible by 7? Okay, so now what we're going to do, so we know it's true for n equals 1, so we're going to assume for n equals k, so that's 3 to the 2k plus 1, 2 to the k plus minus 1 equals 7m. So 3 to the 2k plus 1 equals 7m minus 2 to the k minus 1. And that's what we're going to have to use in the next thing to sub in. So let's prove true for n equals k plus 1. So you get 3 to the 2k plus 1 plus 1. It's required to prove that this is divisible by 7. K plus 1 minus 1, which equals 3 to the 2k plus 2 plus 1 plus 2 to the k, which is 3 to the 2k plus 3 plus 2 to the k, is divisible by 7. Okay, so now what we need to do is we need to sub this in to here somehow. So we need to take this part, which is 3 to the 2k plus 3 plus 2 to the k, and break it up. So it is 3 to the 2k plus 1, because that's what we need to get from that one, times 3 to the 2, because 1 plus 2 is 3. And you want the indices to go back to be the same thing, plus 2 to the k. So in place of this here, we can now put that. So that's 7m minus 2 to the k minus 1 times 3 to the 2 plus 2 to the k. So that there is a 9 now, because 3 squared is 9. And we're just going to expand the brackets. So 7m times 9 minus 2 to the k minus 1 times 9 plus 2 to the k. Alright, so that's 7 9s are 63m. The smallest indice here is actually the 2 to the k minus 1. I'm going to make that a plus as well, because that way I don't have to deal with the negative. I'm going to leave a minus 1 in there, because I want to get the same thing. Actually, it's not a minus 1, it'll be a minus 9, because the 9 there will be what's left. Plus, now this is 2 to the what, so that I get, when I expand that, I've got to get 2 to the k minus 1. So I've got 2 to the k minus 1, I want to get 2 to the k, times what, so then that's 2 to the k. So in order for that to happen, that would have to be 2 to the what? It'd have to be plus 2, because k minus 1 plus 2, now that would give you k plus 1. It would just have to be k to 1. Because if you did k minus 1 plus the 1, you just get the k. So it's just going to end up being 2. So if that's 2, and you close this bracket, that's 63m plus 2 to the k minus 1 times minus 7. And you can see there is a common factor of 7 there. That's 9m plus 2 to the k minus 1. Okay, that's going to be a minus, which is divisible by 7, and therefore by the process of a mathematical induction, this is true for all n greater than or equal to 1.